So let's move on to something different. pH curves. Now pH curves, you have to think about how the titration actually works. Now generally what you've got is a graph of pH versus volume of hydroxide acid added. So you'll start with a strong acid, and you will find that the pH will tend to increase slowly up to the point where you have an equivalent amount of acid or hydrogen ions, acid and base. There you've got a strong acid curve, and of course you've got the strong base curve at the other end as well. Weak acids, higher pH, and weak bases will tend to tail off to a lower pH than the strong base. Indicators, well, each of the indicators will have their own ranges. Phenolphthalein, of course, will have a range, indicator range, there it is, and methyl orange will have its own indicator range as well. And that means that what you need to do is to use the relevant indicator for the particular titration that you're going to be using. So in titrations, follow the curve, and for a strong base you'll use an indicator with an alkaline pH range, such as phenolphthalein. For a strong acid, use an indicator with an acidic pH range, such as methyl orange. Just a few points about titrations. The equivalence point, remember, that's the point where you've got equivalent amounts of acid and base have reacted. So if you've got a 25 cubic centimeters of 1 mole of sodium hydroxide, that will react with 25 cubic centimeters of 1 molar hydrochloric acid. But it doesn't matter whether it's a strong acid or a weak acid. So for example, 25 cubic centimeters of 0.1 molar HCl will react completely with 25 cubic centimeters of 0.1 molar ammonia, even though the ammonia is a weak base and the HCl is a strong acid. Now that's very important when you consider any calculations. Simple acid-base titration calculations, where you're working out the amounts of each that react, doesn't matter whether you're talking about a strong acid or a weak acid, or strong base or a weak base, the equivalence point is going to be at that same point.